Welcome all to Basic Maths Class 17. In this we will discuss the process of finding maxima and minima of a function. So to find out the maxima or minima of a function, you need to follow two steps. First step is, we know that at the point of maxima and minima, the value of dy by dx is equal to 0. So for a given function y is equal to f of x, to find out its maxima or minimum value, we put dy by dx is equal to 0. So if we are differentiating that equation, and if we are equating it to 0, then we'll get the value of x. Then find the value of x. These are the points of maxima or minima, because the condition for maxima and minima is same. Now to check it, whether for a particular value of x, we are going to get a maximum value of y or minimum value of y, we go for a second derivative check. So second step is to check whether the value of x, y is maxima or minima. We use second derivative check. Now we'll discuss what is second derivative check. In second derivative check, we'll find out the value of d square y by dx square. D square y by dx square means nothing but once again we are differentiating that dy by dx. If we are differentiating once, we'll get dy by dx. Once again, if we are differentiating, we'll get d square y by dx square. Let's say it is represented by nothing but f double dash x. So if it is dy by dx, we'll represent it by f dash x, and if it is, we are differentiating two times, it is represented by f double dash x, and we'll put the value of x. And if we are getting the value for this f double dash x is positive, that means the value of y is minima. And if you are getting the value of this f double dash x, means the value of d square y by dx square is negative, then this y is maxima. I know that you will not be able to understand much from that d square y by dx square, or you are having a doubt of d square y by dx square, what is that? So while taking some example, I'll discuss about that. No need to worry about that. Okay. So if we are at maxima, assume that we are at maxima, then again we are changing the value of x. Assume that you are already at maxima and you are changing the value of x, means if you are increasing the value of x, so we can just consider which is nothing but d square y by dx square. So at maxima, dy by dx is 0. Now again we are changing the value of x. Let's say that is represented by d square y by dx square. So if we are at maxima and if I am increasing the value of x, so definitely we know that the value of y is going to decrease. That's why the value of d square y by dx square at maxima will be a negative value. That means again if you are increasing the value of x, if you are at maxima and again if you are increasing the value of x, the value of y is going to decrease. Now just opposite to that, assume that you are at minima, and if you are increasing the value of x, definitely we know that if you are at minima and if you are increasing the value of x, the value of y is going to increase. So at minima, the value of dy by dx is 0, but again we are changing the value of x. So the value of d square y by dx square, it will be a positive value. Means as we are increasing the value of x, the value of y is going to increase. So just remember what is the condition for maxima and what is the condition for minima. If you are getting the value of d square y by dx square is positive, then we are at minima, and if d square y by dx square is negative, we are at maxima. I know that it is somewhat difficult to understand, so we'll take some examples, and along with examples we'll try to understand this concept. Let's say it is given that y is equal to x square minus 2x plus 1, and our aim is to find out what is the maximum possible value of y and what is the minimum possible value of y. For what value of x we are getting this maxima, and for what value of x we are getting the minima. So we can observe what is our first step. Our first step was, for a given function y is equal to f of x, to find out its maxima or minima, we put the value of dy by dx is equal to 0, then find the value of x. So first condition, we need to find out the value of dy by dx. So if we are differentiating this equation, we are going to get 2x minus 2. Now we need to equate this to 0, because at maxima and minima the value of dy by dx is equal to 0, and then find the values of x. So if you are equating to 0, then we'll get the value of x, that is 2x is equal to nothing but 2, or we'll get the value of x is equal to 2 divided by 2, or we'll get the value of x is equal to plus 1. So we can say that at x is equal to nothing but plus 1, we may get a maximum value or we may get a minimum value. That means if I am putting the value of x is equal to 1 in our first equation, the value of y may be a maxima or y may be a minima. But we don't know exactly whether it is maxima or minima. So we can go for the second step or the second derivative check. That means we'll find out what about the value of d square y by dx square. D square y by dx square means once again we'll differentiate this equation with respect to x. So dy by dx is 2x minus 2. Once again, if you are differentiating, differentiation of 2x is nothing but 2 and differentiation of minus 2 is nothing but 0. So no need to we are not concerned with this value over here. We have to just check it whether it is going to be a positive value or negative value. So over here you can observe that we are getting a positive value, as we discussed that if d square y by dx square is positive, that means we are at minima. That means if you are putting x is equal to 1, we will get the minimum possible value of y, and we are not getting any condition for maxima. That means maxima is infinity. So over here we can write at x is equal to plus 1, the value of y is going to be minima. Now we can find out what about the minimum possible value of y while putting the value of x is equal to 1 in our first equation. Our equation was y is equal to x square minus 2x plus 1. In this equation, if I am putting the value of x is equal to plus 1, we'll get it as 1 square, which is 1 minus 2 plus 1. So we'll get the value of y minimum is equal to 0. So we can say that the minimum possible value of y is equal to 0 at x is equal to plus 1. So you can write the final answer like this. The minimum possible value of y is equal to 0 when the value of x is equal to plus 1. And we are not getting any specific maxima over here. That means the maximum possible value of y is infinity or plus infinity when x is infinity. For the better understanding, we'll consider one more question. Let's say y is given as minus x square minus 2x plus 1, and our aim is to find out the maximum and the minimum value of y. So our first step is just find out the value of dy by dx and equate that to 0. So it is minus 2x and minus 2 is equal to 0. So we can write the value of this minus 2x is equal to nothing but 2, or we'll get the value of x is equal to minus 1. So at x is equal to minus 1, we may get a maxima or we may get a minima. We don't know whether we are going to get a maxima value for y or a minimum value for y. So we'll go for the second derivative check. So in second derivative check, we need to differentiate this equation once again, which is represented by d square y by dx square. That is equal to nothing but differentiation of minus 2x is nothing but minus 2, and differentiation of minus 2 is nothing but 0. So over here we are getting a value minus 2. That means that value is less than 0 or a negative value. So if d square y by dx square is negative, it represents that we are at maxima. That means at x is equal to nothing but minus 1, the value of y is going to be maxima. So to find out the maximum possible value of y, we can put the value of x is nothing but minus 1 in our base equation. So our equation was nothing but minus of x square minus 2x plus 1. In this equation, if I am putting the value of x as minus 1, so I'll get the answer as nothing but minus 1 plus 2 plus 1. So I'll get the value of this y as equal to nothing but plus 2. So the maximum possible value of y over here is nothing but 2, and we'll get that value when x is minus 1. So we can write our final answer like this. The maximum possible value of y over here is nothing but 2, and we are getting this value when x is equal to nothing but minus 1. And over here we are not getting a minimum value. That means that minimum value is nothing but minus infinity when we are putting x as minus infinity. Now we'll consider another question. Let's say if it is given that y is equal to 2x cube minus 15x square plus 36x plus 11, and our aim is to find out the maximum and minimum value of y. So we can write, if we are finding out the value of this dy by dx, so we can write this will be equal to nothing but 6x minus 30x plus 36 is equal to 0. So for a maxima or minima, the value of dy by dx should be equal to 0. Now we need to find out the value of x over here. It is 6x square. So the value of x we can find out, and as we are getting a quadratic equation, we'll get two values of x. So this can be modified as x square. I'm just dividing this equation by 6. X square minus 5x plus 6 should be equal to 0. So we can write this is nothing but the product of x minus 3 and x minus 2. That means the value of x is equal to 3 and x is equal to 2. So over here we are getting two values for x. X can be equal to 3 or x can be equal to 2. So we can write it something like this. At x is equal to 3 means if you are putting the value of x is equal to 3, we may get a maximum value or a minimum value for y. Same thing, if you are putting x is equal to 2, then also we may get a maximum value or minimum value. Now at x is equal to 3, whether we are going to get a maximum value or minimum value, we need to go for second derivative check. So once again, we can differentiate this equation. So if you are differentiating this equation, we'll get the value of d square y by dx square. And that will be equal to nothing but 12x minus 30. Now in this equation, if you are putting the value of x, so first if you are putting x is equal to 3, so we'll get the value of this d square y by dx square is equal to 12 into 3 minus 30. So this will be equal to 36 minus 30, that is equal to plus 6. So if you are getting the value of d square y by dx square as a positive value, that means at x is equal to 3, we'll get a minima. Same as like that, if you are finding out the value of this d square y by dx square for x is equal to 2. So if you are putting the value of x is equal to 2, so it becomes nothing but 12 into 2 minus 30. So that will be equal to 24 minus 30, that will be equal to minus 6. So if you are getting the value of d square y by dx square is a negative value, that means at x is equal to 2, we are going to get a maximum value. So now we can find out the maximum possible value and minimum possible value of y over here. So we can write at x is equal to nothing but 3, the value of y is going to be minima. So if you are putting x is equal to 3 on this equation, so on their first equation, so it becomes 2 into 3 raised to 3 minus 15 into 3 square plus 36 into 3 plus 11. So if you are calculating it, you will get the minimum possible value of this is equal to nothing but 38. And same as like at x is equal to nothing but 2, we'll get the maximum possible value for it. And if you're putting instead of x 2 over here, so it becomes 2 into 2 raised to 3 minus 15 into 2 square plus 36 into 2 plus 11. You'll get the answer as around 39. So these are the minimum value and maximum value, or the local maxima and local minima at x is equal to 3 and at x is equal to 2. Hope so that you understood how to find out the maxima and minima of a function. So if you are having any doubt, or if you'd like to interact with me on live classes, or if you want to write online tests for JEE Mains, Advanced or Neet to improve your performance, please let me know. Thank you.